For this example, we will create a user-defined function that will print the reference designator and the XY location of all the components in the PCB editor. We'll start by opening a new text file in our text editor and define a new procedure named compLock that does not accept any arguments. There are multiple ways to get the DBID of all the components in a design, but the most convenient for this example is to start from the design DBID. The axlDBGetDesign function accepts no arguments and returns the DBID of the design that is currently open in the PCB editor. So we'll use the design DBID equals axlDBGetDesign to save the design DBID in the variable design DBID. Now, we can either refer to the Allegro PCB editor skill user guide or use trial and error in the skill interpreter to figure out how to get from the design DBID to each of the components in the design, and then the location and the reference designator for each of those components. I prefer using trial and error in the skill interpreter to figure out how to get the reference designators and XY locations. As we mentioned earlier, the axlDBGetDesign function will return us the DBID for the design that is currently open in the PCB editor. As we saw in a previous training byte, the > operator will return the list of attributes for the design DBID. We see that one of the attributes of the design DBID is the components attribute. So let's try design DBID > components, and we see that a list of DBIDs is returned. If we look at the obj type attribute from the first item in this list, we see that it is a list of component DBIDs. We can now use obj1 > to get a list of attributes for components. Even better, we can use the > operator to get an ordered list of each attribute for the DBID and the value for that attribute. Here we see that the value of the name attribute is U38, which is its reference designator. So now we know that > name operator for a component DBID will return the reference designator of the component. None of this information seems to give us the XY location of the component, but we must remember that a symbol is the physical instantiation of a logical component, and if we try the > symbol operator on the component DBID, we get a new DBID and we can find out that it is a symbol object using the > obj type operator. Using the > operator on the symbol DBID shows that it has a member attribute of XY. Using the > XY operator on the symbol DBID returns the XY location. So now we know that object 1 > symbol XY will return the XY location of the component obj1. We now have all the information we need to go back and complete our user-defined function. We'll use a foreach loop to loop over all the components in the design, and for each component, we can now get the reference designator and the XY location of the component. We use the printf function to print the reference designator and the XY location, and this completes our loop, and we can now save and load our function and give it a try. We did print the reference designators and XY locations that we wanted, but the return value of our function is the list of DBIDs that we iterated over, which is a bit inconvenient. Let's add one more line after our loop. That returns the length of the list we iterated over. So our function will return an integer with the number of components in the design, rather than a list of all the component IDs in the design. In summary, we can see that it is practically trivial to write a user-defined skill function that will print the reference designator and XY location for every component in the design that is currently open in the PCB editor.